This is R.D. Sharma Solution, Class 12, Chapter 10, Differentiability. Exercise is 10.1. So before we go ahead, let's talk about what is differentiability. Differentiability, before that we have to know about continuity, because differentiability only comes after continuity. So if a function is differentiable, that means it is continuous. But the inverse is not true, converse is not true. That means if a function is continuous, that doesn't guarantee the function is also differentiable. So if we have a function, we need to check its certain point. Please remember that dy by dx is the differentiability, and we are indeed talking about the rate of change of y with respect to x at that particular instance, that is at that particular point. Because average speed can be computed, constant speed can be computed. What about a particular point? What is the speed? What is how the y is changing with respect to x? That will be known by the tangent at that point. So if fx is a real valued function, and that is defined in an interval, open interval a comma b. So if we take a point, say any point k or c, and we are interested in finding out whether the function is differentiable at this point c or a k or whichever constant you take. So c is belonging to a comma b. So the fx, the differentiability of fx, that is f dash x, will exist if limit x tends to c, that is the point we are checking. The limit x tends to c, fx minus fc, that is we are checking at the value c, fx minus fc divided by x minus c, this is finite, this exists. It is not of the form of 0 by 0, infinite by infinite, 0 by infinite, or infinite by 0, like that. Then we say that this function is differentiable at point c. So basically we are interested in what? The tangent. So how to find out? In continuity, what did we do? We just go back a bit, we just move front a bit. That is, we go to the left hand limit and the right hand limit and try to find out whether they both are equal or not. That is, there are no two tangent but a single line whose slope is equal to LHL and RHL. Okay, left hand limit and right hand limit. Same way, the left hand derivative and right hand derivative we are going to compute. That means the left hand derivative has to be equal to right hand derivative. That is, we are interested in just one tangent rather than having chords. And that tangent slope is the differentiation. So we go c minus, we go c plus. That is, just go a bit behind c and go in front of c. So if you are checking at, say, some point c which is in the interval a and b, so c minus and c plus, that is the left hand derivative, we assume it to be, say, c minus h, that is we are going just a bit backward. C plus h, that is we are just moving in front of this c. C can be any value, it is between a and b. You have to check the differentiability at that c. So what we are trying to do that left hand limit, right hand limit. Same way here, left hand derivative, right hand derivative, they ought to be same. There is one line, only single one line. There are no multiple lines. Otherwise, there are multiple lines. That means it is having two slopes. So fc minus h minus fc divided by c, this in place of x write c minus h minus c. That is, we are replacing x by c minus h. Here we are replacing x by c plus h. So fc plus h minus fc divided by, in place of x, replace it by c plus h minus c. So this as we just indicated in the previous differentiability, limit is x tends to c. Since x is c minus h, the limit will change. It will be h tends to 0. Limit h tends to 0, and that's these two has to be equal to similar, that is they are equivalent. If they are equal, that is it is differentiable. If they are not equal, they are not differentiable. That is f dash x exists or f dash c exists, that is differentiability. So there is one tangent, one slope, one line. Any graph, we generally do some two lines, and then we try to make these chords, the points, that the 2 points become one, and that 2 points can become one when we apply the limit, and that if that becomes one line, that is differentiable. This is the question where we have a modulus involved. Show that fx equals mod x minus 2 is continuous but not differentiable at x equals 2. So if the function is continuous, it may be differential, it may not be differential. But if the function is differentiable, the function has to be continuous. Okay? So most of the people, they ask me that you show the answer, so what is the point in solving it? See, answer is always with me. I can just see and write and solve it. The whole idea is that you are going to solve it in your examination. So you need to have a fair idea how are you going to write it. The way you should write it in your exams, the way you write it in your copies. Okay? Now why it is important to show it? Because sometimes some people know the solution. So they would just like to have a look and go ahead rather than listening to all 3 or 4 or 5 minutes of solution. But there are certain people who would like to see also and like to know the logic and reasoning one by one step. So if the answer is between them or in front of them, they will be able to appreciate the solution which I do. Okay, let us start the solution. Now what is the modulus? Modulus x. It just means that it will be equal to x when x is greater than 0 or equal to 0. So this is a number line. We are talking about x equals 0. So mod x will be equal to x. When you go on the left hand side, when x is less than 0, it is going to be negative x, because x will be negative and negative or negative x will be positive. Right? That is how you get always positive out of the modulus. Modulus always give you a positive value. So how do you get the positive value when x is less than 0? You put a negative in front of it. Negative x is positive. Okay. Now when we have the x minus 2, x plus 1, that means the modulus is same, but now it is not 0. Left and right, we don't have to check at 0, but at say x minus 2 equals 0 is what? X equals 2. So now it has been shifted. It is not, we have to check at x equals 0, but x equals 2. So the same logic, but the point is now shifted to 2 when x minus 2 is 0. If it would have been x plus 1 equals x plus 1 modulus, it would have been x equals minus 1. So above 2 it will be x minus 2 positive, below 2 it will be negative of x minus 2. Same logic. Right hand side it will be plus of x minus 2, left hand side it will be negative of x minus 2. That is minus x plus 2. Okay. So this we are going to use in our solution. I hope you got the idea. Now after this question, mostly we will be solving the differentiability. Because this is the first question, we will also talk about the continuity. That is how you are going to relate, how this continuity is relating or giving rise to the differentiability. Right? Differentiability is nothing but the rate of change. For example, speed is distance by time. So how the distance is changing with respect to time, or at particular point, what is the instantaneous speed at that particular point, that is known by the tangent. The slope of the tangent is given by d by t at that particular instance. That is called the differentiation or the derivative, and if it is possible, it is called differentiability. So we'll start with the continuity in this question. And most of the questions coming will only ask us for the differentiability. But here continuity is also involved. So let us check it. See, x is equal to 2. So we are going to check at x equals 2. So when we go on the left hand limit. When we go on the right, it is going to be right hand limit. So when we go back, there will be some value deducted from 2. So 2 minus h will use. When we go in front, some small value will be added to that 2. So 2 plus h it will be. This h is very small. It is just equal to 0 but not equal to 0. Very small value. So limit, let us apply the limits, and of course what we are going to do, this is limit x tends to, how do we write this? X tends to 2 minus, because we are going on the back side or behind it. In front of it we will use x, limit x tends to 2 plus. So limit x tends to 2 minus, it is fx. So x has to be written as 2 minus h in this case. So when we replace x by 2 minus h, what it will be? So it will be h, limit h tends to 0, replacing x by, because we are going on the back side of x. So what is x less than 2? We have to use minus x plus 2. That is, in minus x plus 2, we have to replace x by 2 minus h. So we are doing it on the left hand limit and right hand limit also. So right hand limit will be saying limit x tends to 2 plus fx. And when we replace this x by 2 plus h in x minus 2, it is going to be limit h tends to 0. Okay. So x greater than or equal to 2, x less than 2. This is how we are going to use it. But we know when we have x equals 2 minus h, we are going to use x less than 2, which is negative x plus 2. Replace 2 minus h in place of x in negative x plus 2. That I already explained it to you. So this is going to be limit h tends to 0. And we have minus x plus 2. So in place of minus x plus 2, x replaced by 2 minus h. Minus x is 2 minus h plus 2. And here we have limit h tends to 0. So now we are going greater than 2. And for that we have to use x minus 2. So in x minus 2, replace x by 2 plus h. So 2 plus h minus 2. Okay. Now what you are going to get is minus 2 plus h plus 2, and here you have 2 gets cancelled, h, here also you get 2 to cancel, you get a h. So both ways you get limit h tends to 0, h. When you apply the limit, it is going to be 0, okay. So LHL and RHL, they are both equal. That means the continuity is there. It is continuous. This function is continuous. Okay. This is continuity. This is the first step. Now we have to check for the differentiability. So if the function is not continuous, it may be differentiable, it may not be differentiable. Okay, this will remain. What I told you in the earlier discussion. Mod x minus 2 is the opening of this is independent of other things. Mod x minus 2 is x minus 2 when x is greater than or equal to 2. Mod x minus 2 is minus x plus 2 when x is less than 2. So we are coming to actual differentiability now. So the discussion point of this whole exercise is differentiability. Okay. So x equals to, this is differentiability. So I'm writing it short dy. So left hand derivative we are going to find out. Right hand derivative we are going to find out. LHD and RHD. Same curve, it can be any curve. At point 2 we have to check. So we have to go just a bit behind, just a bit front. That is some value h. So the first principle we are going to use. First principle. Okay, so this limit x tends to 2 minus, limit x tends to 2 plus. Okay, 2 minus and 2 plus. So this we are going to say f x minus fc divided by x minus c. Since c is 2 here, we have fx minus f2 divided by x minus 2. Okay. And then we have fx minus f2 by x minus 2 same way in limit x tends to 2 plus. So x we are going to replace on the left hand derivative by the same way we have done in the, you don't have to do this 2 minus h here, you can do it. I'll show it in your next question. So next question you will see that I am going to put this x as 2 minus h or whichever constant is there. But here it's simply minus x plus 2 you write, because you know what is the value when x is less than 2. f2 is you can directly get the value f2, just put it here. So 2 minus 2 is 0, mod 0 is what? It's going to be 0. fx, this is mod 2 minus 2, that is mod 0. And then you have this mod 0 is what? It is going to be 2 minus 2 0, mod 0 is 0 only. So in both left hand derivative and right hand derivative I am going to put f2 as 0. So minus x plus 2 minus 0 divided by x minus 2 here. Here we have again same thing, fx in place of fx, because you are going just a bit ahead of 2 plus something. So you have to use x minus 2 here. So x minus 2 and minus, of course f2 was 0 as I just told you. Then x minus 2 in the division. So you have minus x plus 2 divided by x minus 2, and in the numerator you can just take negative constant. So you get x minus 2 in the inside the brackets. You can cancel these two, you will get a negative 1. On right hand derivative, it is going to be 1. X minus 2 gets cancelled with x minus 2. So limit x tends to 2 minus limit x tends to 2 plus, both the cases. So no, see, please remember, when we replace this 2 minus by minus x plus 2, the limit also changes. It will be simply limit x tends to 2. When we replace fx by x minus 2, the limit is not 2 plus then. It will be simply limit x tends to 2. So you get a negative 1 and 1. That means you have a LHD and RHD, they both are not equal. When we put 2 minus h and 2 plus h, it is going to be, again, you'll find it that it will be not equal to 0. So since the left hand derivative and right hand derivative are not coming equal, the left hand limit and right hand limit were equal, they were 0. But the left hand derivative and right hand derivative, they are not coming equal, they are negative 1 and 1. So fx is not differentiable at x equals 2. Show that fx equals x raised to the power 1 by 3 is not a differentiable at x equals 0. So x raised 1 by 3 is nothing but third root of x. Okay. So this is not differentiable at x equals 0. So what do we do here? You have to go, if you want to go to continuity, you can go to continuity, show that it is continuous or not continuous, it's up to you. But the question is simply asking about the differentiability. So we will be checking about the differentiability here. Right? And here we are going to use that 0 minus h and 0 plus h. Same way we were doing it in the continuity theory. Same way we are going a bit left, bit right of 0, because the point of contention of checking the differentiability is x equals 0. So here we have a 0. This is x equals 0 minus h. This is x equals 0 plus h. This is what we are going to put. Limit x tends to 0 minus. Here limit x tends to 0 plus, because at 0 we have to check or find out the differentiability. Fx minus fc by x minus c. In place of c, the x is given as 0. So it will be fx minus f0 divided by x minus 0. I'll write it as x only. Here fx minus f0 divided by x minus c. C is of course 0, so it will be only x. Okay. Now this left hand derivative and right hand derivative, fx is what? Fx, you just replace it by 0 minus h. On right hand derivative, replace it by 0 plus h. So limit will change. Limit h tends to 0, it will be fx, just put x as 0 minus h. So it will be f, in place of 0 minus h, it's just minus h only. 0 plus h is simply h. Okay. So fx What is this? Third root of x. So when we replace this f minus h, it will be third root of negative h. And negative h to the power 1 by 3 it is eventually. So I am writing it directly. So minus h to the power 1 by 3 minus f0 is what? Third root of 0, any root of 0 is going to be 0 only. Third root of 0 is 0 only. So just write 0. And in place of x, write minus h. So this is minus h to the power 1 by 3 divided by minus h. Now just minus h you can take in the numerator because it is limit h tends to 0. So this you have to write everywhere. That's why I am showing you the solution on the left hand side. When it goes up, it is going to be negative h to the power minus 1. So the power is going to be added because x to the power a into x to the power b is x to the power a plus b. xa xb is xa plus b. Okay. So 1 by 3 plus minus 1 is going to be negative 2 by 3. I hope you got the idea. The power add if the base is same. So 1 by 3 minus 1 is going to be 1 minus 3 by 2, that is going to be negative 2 by 3. So minus h to the power minus 2 by 3, limit h tends to 0. Now whatever h can be, h is 0. Okay, whatever is the power, it doesn't matter, it is going to be 0 only. I hope you got the idea. Okay. Then my h to the power 1 by 3. Again h to the power 3 and f0 is 0 only. And x is h only. Right. So either this h, if you can take on the left hand side, I am saying if you take minus 1 to the power minus 2 by 3 into h to the power minus 2 by 3, then also it is going to be 0 because one term is 0. When you have any term, when you multiply multiple things and one of the term is 0, it is going to be 0 eventually. So here we have h to the power 1 by 3 and h to the power 1 in the denominator. Same way when we did in the left hand side, this h to the power 1 by 3 divided by h to the power 1 goes up. So it will be h to the power of minus 1. So h to the power 1 by 3 into h to the power minus 1. 1 by 3 and negative 1 gets added. It is going to be h to the power minus 2 by 3. Again, whatever you do with h doesn't matter because it is going to be 0. H tends to 0. Anything to the power 0 is going to be 0 only. So you have a 0 on left hand derivative and right hand derivative and they are not equal. When they are not equal, that means this x raised 1 by 3 is not differentiable at x equals to 0. So this question, I don't know, in our perspective, in our solution it is not coming as equal, so it is not differentiable. The question is saying show that it is not differentiable at x equals to 0. In our case, both are coming 0, so it may be differentiable. We don't know, but as the answer goes, as the solution goes, it is differentiable. Right? Show that fx is equal to these two functions when x is less than or equal to 3 and x is greater than 3. So there are two functions here and we have to show that they are differentiable at x equals 3. Also we have to find f dash 3, that is the derivative of this function. So differentiability, continuity, all are related. So this is the point 3. Now before that 3 value, the function will be simply 12x minus 13. So this is an equation of a line. So this can be a line. You can make any line just to understand. And there will be 2x square plus 5. There is a function when x is greater than 3. So when you are below 3, you have to use the function 12x minus 13. When you are above, you have to use 2x square plus 5. Okay. So when the differentiability can be proven, the value will come and you don't have to differentiate again. That will be the value of the f dash 3. So left hand derivative and right hand derivative, that is what we are interested in. So we just write it by 3 minus 3 plus to indicate we are dealing with 3 minus left hand derivative, 3 plus right hand derivative. So you have limit extends to 3 minus. So you are going just backwards than 3. You are moving just forward to 3, that is x tends to 3 plus. So how do we check the differentiability? Fx minus fc by x minus c, limit extends to c. If this is a finite entity, this has certain value that can be comprehended, then that is what is differentiability. What is c here? In this case, c is 3. So we have fx minus f3 divided by x minus 3. Here also fx minus f3 divided by x minus 3. Same thing here. Only the fx and f3 has to be changed in both the cases. The fx when x is less than 3 is 12x minus 13, and f3 is what? Just see, x is less than equal to 3. So you have to use this function in both left hand derivative and right hand derivative. So 12 into 3, just put x as 3, 12 into 3 minus 13. So 36 minus 13, it is going to be 23. Just replace f3 by 23. X minus 3, so just you can keep it like that. So I'm not going to write this again, just assume that this is always there. That's why I show you the answer so that you know how to write it. Now you have fx minus f3. Now since x is greater than 3, you have to use 2x square plus 5. And since x is equal to 3, always you have to use 12x minus 13. So f3 means you have to replace x by 3 in 12x minus 13, that we already computed, and that has come to be 23. So 2x square plus 5 minus 23 divided by x minus 3. So let us solve this one. It is going to be 13 plus 23 is 36. So it is going to be 12x. So this is going to be 36. 12x minus 36. And if you take 12 common, it will be x minus 3. X minus 3 is always in the denominator. So you have 12 as the left hand derivative. This is your left hand derivative, okay? Now coming to the right hand derivative, what do you see here? This 5 minus 23 is negative 18. 2x square minus 18, just take 2 common, x square minus 9 it will be. And divided by x minus 3. So this x square minus 9 can be written as x square minus 3 square. You can use a square minus b square formula as a minus b, a plus b. So it will be x minus 3, x plus 3. X minus 3 is already in the denominator. Okay. So you already have a denominator. You can just cancel these two out. 2 into x plus 3, it will be there. Now since it is continued, limit extends to 3 now. Replace x by 3. So 3 plus 3 is 6. 6 into 2 is again 12. See, limit has changed now. Since we replaced fx by 2x square plus 5, now it is x tends to 3. So both the ways, left hand derivative and right hand derivative we computed, and that has come to be 12. What is f dash 3? It is just the left hand derivative or right hand derivative. You can take any of it because they are eventually equal. This is 12. Answer is 12. Show that the function f defined as follows is continuous at x equals 2 but not differentiable at these. So you have to show it to be continuous, and you also have to show that in spite of being continuous, it is not differentiable. Alright? So you just see the variation. These intervals are very important. And we always check in between where the function is changing. From 0 to 1, it is 3x minus 2. You have to use this function. Between 0 and 1, you have to use a. I'm just assigning it to be a. Second function, let us say it is b. So between 1 and 2, you have to use this. And above 2, you have to use the function 5x minus 4, c function. So the continuity first to be computed. So this continuity, see, left hand limit, right hand limit, and if LHL, RHL is equal to the value of the function at that value which is given as 2 here, that we will see. So LHL, RHL, we have the point of contention or point of to be checked is x equals 2. So x equals 2 minus h on the left hand limit, x equals 2 plus h on the right hand limit. Okay, but please see, when you go above 1, you have to, this below 2, that is b function you have to use. So 2 and 2 minus h whole square, because I'm replacing x by 2 minus h, and then again 2 minus h. So 2, you can just open it. See, you have to do it like that. You have to open it properly and then put h equal to 0. Not like this. I know because what I'm getting, so I just did it. So the final thing will come as 6. And you have to write all this. See, I'm just skipping it because on the left hand side I showed you the answer, because you have to write like that. Right hand limit, you're going above 2. When you're going above 2, it is going to be 5x minus 3. So in place of x, write 2 plus h minus 4. So this h goes 0. 10 minus 4 is going to be 6. So you have to show that the function is defined, and this is continuous at x equals 2. So left hand limit, right hand limit are equal. And what is the value of the function at 2? Where 2 is equal? See, x is equal to 2, less than or equal to 2. So you have to use 2x square minus x function. 2 into 2 square minus 2, 2 into 4, 8, 8 minus 2 is 6. So what they have asked, we have done it. LHL, RHL and value of the function at this 2 is equal. So this is about continuity. Now next thing is the differentiability. So in order to find out the differentiability, we have to take a step ahead. So what is the step ahead? Please remember, the LHL and RHL we have found out. Here we are going to find out the LHD and RHD, left hand derivative and right hand derivative. Again at the point 2. So left hand derivative, it will be limit x tends to 2 minus, just to show that we are going a bit backwards. Limit x tends to 2 plus, just to show that we are just going a bit forward. So fx minus f2 divided by x minus 2. This is going to be left hand derivative x minus 2. And right hand derivative is fx minus f2 divided by x minus 2. Okay. So what we have got is fx minus f2 divided by x minus 2. So I'm doing the left hand derivative first, and then we'll go to the right hand derivative. Now you see, when we computed for the continuity, left hand limit, so fx was what? Is 6. And what is f2? Again 6. 6 minus 6. So you're going to get a certain different result here. But we have to do it differently. We have to write x as 2 minus h here. So see, fx was already, we computed just now, is 6. f2 is 6. So we cannot do it like that, because it will be 0 ultimately. We have to take proper steps so that the denominator gets cancelled. Okay, so 2 into 2 minus h whole square. And because we are going below 2, so you have to use 2x square minus x function. In the x, you have to write 2 minus h. So I have used 2 minus h in 2x square minus x. And of course, you have f2 as 6. So minus 6. So what do you get in the numerator? I'm just opening it. A minus b whole square. And then this is minus 2 minus h minus 6. Just open this. And denominator is negative h. We'll just use this negative h just now. So 8 plus 2h square minus 8h minus 2 minus h minus 6. Now what do you see here? See, 8 is there, minus 2 is there, minus 6 is there. So 8 minus 8 is 0. So all these 3 will vanish. You will get 2h square minus 8h minus h. Now take h common from here. So you will get 2h minus 8 and minus, this is going to be 1, minus 1. And denominator is what? Minus h. So h gets cancelled. Okay. So minus 2h. And this is going to be, it's going to be, see, minus 2h plus 7. I'll just change it, okay. It is going to be only 7, because when you apply the limit, it is going to be 7. There is slight change here. It's going to be 7, okay, because h gets cancelled. It was minus 2 plus h. Now same thing we are going to do for the right hand derivative. So limit x tends to 2 plus, that is x equals 2 plus h, you have to write. Fx minus f2 divided by x minus 2, same thing. Fx, so x equals 2 plus h. Now you have to use the function fx minus 5x minus 4. So 5 into 2 plus h minus 4 minus 6. Same thing here, just open this. So it is going to be, we just open it, 5 2s are 10, plus 5h, minus 4 minus 6. So minus 4 minus 6 is negative 10. Negative 10, 10 cancels. You have 5h. And in the denominator, what do you get? X you have to replace by 2 plus h. So 2 plus h minus 2. This 2 gets cancelled. H it is. H gets cancelled. You have a 5. So when you apply, you don't have to apply the limit because it has a constant. So left hand limit was 7. Right hand limit is 5. So left hand limit is not matching with right hand limit. That means this function is not differentiable at x equals 2. Okay. Now discuss the continuity and differentiability of this fx equals this. This in the continuity discussion we have done it a lot. Okay. So minus 1 to 2, this is whole C interval. So you have to check in the phases in different partitions. So let me just make it like this. You have a 0 here, you have a negative 1 here, 1 and 2. So negative 1 and 2 are not of that importance right now. 0 and 1 is important because it is between minus 1 and 2, and at 0 and 1 the function changes. So mod x is x when x is greater than 0. It is going to be negative x when x is less than 0. That we already know. What is mod x minus 1? Mod x minus 1? See, it means x minus 1 equals to 0. So x equals 1. The point is 1. So below 1 it is going to be negative, and above 1 it is going to be positive. So x minus 1 for x greater than 1, and when x is less than 1 it is going to be negative of x minus 1. So you can write this negative of x minus 1 like this, minus x minus 1. So minus x plus 1. You can always write it as 1 minus x, or it can be minus x plus 1, whichever way you want. Okay. Now we will make the intervals. Minus 1 to 0 what is happening, 0 to 1 what is happening, and 1 to 2 what is happening. For whole function, mod x plus mod x minus 1. So fx in the interval of minus 1 to 0, that is the first interval, what do you get? This mod x, because it is 0, less than 0, so it is going to be negative x. Negative x. And since you are still below 1, it is going to be negative x minus 1. Just check what we are dealing with. We are between minus 1 and 0. So you are below 0. And below 1, mod x minus 1 is negative. Below 1 and below 0, mod x is negative. So just write negative, negative. So minus 2x plus 1 for minus 1 to 0. I hope you got the idea. Now it's the second interval. Fx, the second interval is 0 to 1. So 0 to 1 is the second interval. Now when you go above 0, mod x will become positive. So it will be positive x. But still the mod x minus 1 is going to be negative because you are still below 1. You are above 0 but you are still below 1. So you have to again use this 1 minus x. X gets cancelled, you get a constant 1. Alright. Now coming to the third interval, fx, 1 and 2. So when you are between 1 and 2, this both are positive. You are above 1. So x plus x minus 1, this is going to be 2x minus 1. Now this 3 we are going to use in this solution of this question. Because I am going to take you to the continuity first and then the differentiability. If it is continuous, it may be differentiable, it may not be differentiable. But if it is differentiable, it should be definitely continuous. Right? So there is no point in checking the differentiability if you have to check the continuity, because differentiability doesn't point to continuity. Differentiability point to continuity, but continuity doesn't point to differentiability. It may not. So just watch very carefully. I am going to do it. As I said, we have minus 1 to 2. We have 2 points, 0 and 1. That is where we are going to check. Because x becomes 0 and x minus 1 also becomes 0 in between. So LHL and RHL I am going to use at x equals to 0. So what you can do is you can put always 0 minus h on the left hand side, 0 plus h on the right hand side. That's so always you can do. So 0 minus will write. You can always write 0 plus h, but I am going to write 0 plus because we already know what is going to come because we have already solved it, right? So x says 0 minus h. 0. What are you going to use? See, I already told you that in minus 1, 0, this is 1 and 2. So when you are below 0, what are you going to use? That is in the interval minus 1 and 0, what did we get? Minus 2x plus 1. This one. Because below 0. So minus 2x plus 1. Now apply the limit. Limit extends to 0. So this minus 2 into 0 will be 0. You get a 1. This is going to be 0. You only get 1. What about the right hand limit? You are going above 0. When you go above 0, that is between 0 and 1, you are going to use 1. That was a constant. So there is no point in applying the limit because it is already a constant. So left hand limit and right hand limit, they have become equal. LHL and RHL are equal. So that means x equals to 0, it is continuous. Now we are going to check at x equals to 1. Same thing we are going to do. Okay. When you are going to check at x 1, LHL will be x tends to 1 minus, RHL will be equal to x tends to 1 plus. So 1 minus h, 1 plus h you can always use. I am not going to use it because already we have solved it. We know what are the values in these intervals. These already 3 things. I explained it to you. So we don't have to go for 1 minus h, 1 plus h. The situation or the way of solving will be same. It will be same. Okay. So when we go on in the interval 0 to 1, we know it is 1. When we are above 1 plus, that is 1 to 2, the interval 2x minus 1. Apply the limit here, x tends to 1 because you have to check for x equals 1. So 2 into 1 minus 1, that is going to be 1. So you have 1 and 1 on the LHL and RHL for the x equals to 1. So what do you get? It is continuous. Continuity has been checked. Now from minus 1 to 2, you have 0 and 1. You have already checked continuity at 0 and 1. So the limit is existing. The continuity is favorable to us in this case. What about the differentiability? So when we go to differentiability, fx we know already, minus 2x plus 1. So what will be f dash x? That is the differentiation. You already know the differentiation by now. In the interval minus 1 to 0, we have already found out fx. What is f dash x? When you differentiate it, 1 will be 0 and x will be 1. So minus 2 it will be. Now f dash x in the interval 0 to 1, what will be there? It was 1. So when we differentiate 1, it is going to be 0. We have to take the differential of this, what we have found earlier for the continuity. Now this is 2x minus 1, so what will be f dash x? F dash x for 2x minus 1 is going to be in between 1 and 2. 1 is 0 and when you differentiate 2x, it is going to be 2 only. So minus 2, 0, 2. Now you don't have to go for all that thing, x tends to 0 minus 0 plus 1 minus 1 plus y. Because if you check it at x equals to 0, when you go to left hand limit 0 minus 0 plus, why to apply the limit? Because it is already a constant. F dash x is already constant. So when you go, just backwards of 0, minus 1 to 0 you are trying to find out. It is going to be negative 2. It is a constant. You can apply the limit. You can always do that, this 0 minus h and 0 plus h, all I explained you earlier. But it is not required here. Minus 2 is constant. So just write minus 2. When you go from 0 to 1, it is going to be 0 because it is already a constant f dash x. I already told you. When you go just backwards or below this 1, it is going to be 0. Above it is 2. Minus 2 is not equal to 0. That is left hand derivative and right hand derivative not equal for x equals 0. This is not RHL. This is just the derivative basically. So the left hand limit and right hand limit for the derivative, they are not equal at x equals 0 and x at x equals 1. Okay. Now we have here, find whether the function is differentiable at x equals 1 and x equals 2. So this function, we have 3 partition actually. Till now we have talked about the continuity, but here we will talk about the differentiability. Please remember, d by dx of x is 1, d by dx of 2 minus x is what? 2 is 0, x is of course 1, so negative 1 it will be. What is the d by dx of negative 2 plus 3x minus x square? So it will be minus 2 will be 0 because it is a constant, 3x will give you 3 and x square will give you 2x. So 3 minus 2x is your differentiability. Now this f dash x, see, we have to check the differentiability. So what we'll do, we'll change the function fx to f dash x. I just told you what will be the differential, what will be the differentiation. So fx minus fc by x minus c, this is how we do it. But you don't have to worry about this because already the functions are given, we can just differentiate them. Okay, and what are the partitions? These partitions are, or you can say the intervals are different. Let us write this f dash x because we have just make the differential out of it. But we have to check whether it is differentiable at x equals 1 or x equals 2. Okay. So f dash x, I just told you differentiation of x is 1, differentiation of 2 minus x is negative 1, differentiation of negative 2 plus 3x minus x square is 3 minus 2x. This is when x was less than or equal to 1, this is when x is between 1 and 2, and this is when x is greater than 2. Okay. Now we will do the left hand limit and right hand limit, not for continuity but for the differentiability. We'll do the same thing but for differentiability. Okay. So this is left hand limit for differentiability, and we'll try to LHD we used to find out, but we have already taken the differential. So we will do the right hand limit and left hand limit for the differentiability, for the differentials, for the derivatives which we just found out. That is, we want a point and we want a tangent. We want to look for the tangent. So that tangent means the LHL has to be equal to RHL for the function which is given to us. Okay, you don't have to do anything for the constant. Whatever you do, if you use limit 1, because the function is 1. The differentiation of x is 1. So we are going to find out the differentiability at 1. So x equals 1 minus h, 1 x equals 1 plus h, you can write. So the first function, when you are 1 minus, that is you are behind 1, so it is just 1 because the differentiation was 1. Again here you have what is the value? Negative 1. So whatever you apply 1 plus h or whatever, it won't affect because it is already a constant, and 1 is not equal to minus 1 because there is no x in both of it. Left hand, right hand, there is no h. So 1 and negative 1, that means the left hand limit and right hand limit of the derivative of this function at x equals to 1 is not matching. It is not matching. Okay. Now coming to the point x equals 2. Now as I said, we have different partitions. So x is less than or equal to 1, 1 to 2 and greater than 2. So when we have to find out for 2, and when you go on the left hand side of 2, that is x equals 2 minus h, you are going to write, and x equals 2 plus h you are going to write. When you are below 2, it is 2 minus x, and differentiation of 2 minus x is negative 1. So again you don't have to do anything because it is a constant. You don't have an x there. So you cannot apply a limit, you can't do anything. It is negative 1 always. But in the differentiation of minus 2 plus 3x minus x square, which is 3 minus 2x in our case, so we will put 2 plus h here. So you'll get 3 minus 2 to the 4 minus 2h. Now you apply the limit h tends to 0, this goes 0, 3 minus 4 is negative 1. Now you see the negative 1 left hand limit and right hand limit for the differentiation at x equals to 2 is equal. That means the function is differentiable at x equals 2. It was not at 1 but it is at 2. This is how you are going to write, okay, in your examination or in your paper. show that the function this is continuous but not differentiable at x equals 1. So we have two different functions. Actually, it is three different functions. This function, the first function is mod 2x minus 3, and then we have the greatest integer function. If I can see it clearly, the greatest integer function of x when x is greater than or equal to 1. That is when you go up x. When you go up 1, it is going to be this function. When you are below 1, then which function are you going to use? You are going to use this sine pi x by 2. Okay. So you have to, the question is asking, you have to find out that this is continuous but not differentiable at x equals to 1. So we will check the continuity first. So at x equals to 1, we'll find out the left hand limit, we'll find out the right hand limit. The left hand limit will be x equals 1 minus, or you can say 1 minus h you can put, and x 1 plus h you are going to put. You can just write it as 1 plus, that is equivalent to 1 plus h, or 1 minus is 1 minus h. Okay, when you go below 1, it is going to be sine pi x by 2. Sine pi, in place of x, just write 1 minus h, because that's what you have to put, because you're going just backwards of 1. So sine pi by 2 minus pi by 2 h. So sine 90 minus theta it is. See, it is pi by 2 into 1 minus h. So I just multiplied it inside. Pi by 2 minus pi by 2 h. Sine 90 minus theta is cos theta. You can put h0 there, or you can put h here also. That is, if you apply the limit here only, that is pi h by 2, you apply limit here, then sine pi by 2 will be equal to, because it will be sine 90. Sine 90 is 1. Or the better way is to do the cos. So cos sine by 90 minus theta is cos theta, cos pi h by 2. When you apply limit h tends to 0, it is going to be 1. Cos 0 is 1. Coming to the right hand limit for the continuity at x equals to 1, we will put a 1 plus h in this mod 2x minus 3. So 2, I am writing 1 plus h here, minus 3, and the greatest integer function, we are going to put x as 1 plus h. Now you have to know the property of the modulus and the greatest integer function. So this is 1, this is 2, 3. So in this greatest integer function, whichever value is between 2 and 3, it will go to 2. Whichever value is between 1 and 2, it will go to 1. So 1 plus h means very small value added to 1. So it will always go to 1. So greatest integer function will give you result of 1. How about this h tends to 0 for mod of this? I hope you got the idea. Modulus of this. Please remember, you are below this greater than 1. Okay. So you are greater than 1 and you are using just 1 plus h. It's very small value addition of 1. So I'm just opening it, 2 into 2h minus 3. So this 2 minus 3 is negative 1, 2h minus 1. Apply h equals 0. So you are going to get negative 1 in the modulus, it will be 1. 1 multiplied by 1 is 1. So the left hand limit and right hand limit are equal. LHL and RHL are equal. So this function is continuous at x equals 1. Right? It is continuous at x equals 1. Now let us come to the probability, differentiability, sorry. So continuity we have shown already. Now differentiability we have to show. Because continuity doesn't mean or doesn't guarantee the differentiability, but differentiability guarantee continuity. You would have checked for differentiability, but for that you have to go, if it is differentiable, not differentiable, you have to go back to continuity. But we are checking the differentiability. Simple definition of differentiability is fx minus fc by x minus c, limit x tends to c, c minus will do, c plus will do, that is on the left hand derivative, right hand derivative will find out, and try to find out whether the value matches or not. So at x equals to 1, left hand derivative I am taking, on right hand derivative I am taking, of course you have to do the same thing, 1 minus h and 1 plus h. You have to write the same function, that is fx minus fc by x minus c. This is nothing but the solution of a differentiation by first principle. This is just first principle method. And since we have this c as 1, so I am just putting as 1. Again fx minus fc divided by x minus 1, because your c is 1 in this case. Okay, what is the value of because the function when you have x greater than or equal to 1, this function you are going to use. So here on the right hand side, right hand derivative, you have used 1 plus, left hand derivative is 1 minus. Okay, so you have to see which function you have to use. When you are above 1, x equal, you can say x 1 plus or 1 plus h, left hand derivative 1 minus h or 1 minus, you can say. So fx will be, in the left hand derivative, it will be sine pi x by 2. Sine pi x by 2. Sine pi into x, in place of x, write 1 minus h by 2 and minus f1. Now f1 in both the cases will be same. f1 will be what? See, where is the equality? X is greater than or equal to 1. So equality is here. So x is greater than 1, x is equal to 1. That means x is greater than or equal to 1, which we have to use here. So just put it here. 2 into 1 minus 3. And greatest integer function of 1 will be 1 only. It is already a integer function. Integer. So 2 minus 3 is negative 1. Modulus of negative 1 is 1. So minus this 1 into 1 is going to be 1. So in both the cases, LHD and RHD, I am going to put 1. Here also same thing. Fx, because you are going to right hand derivative, so you are going to use this one. Modulus of 2, and in place of x, just write 1 plus h and minus 3. And then you have this greatest integer function of 1 plus h minus 1 by x minus 1. Now you can very well see that x minus 1 in the denominator. So you will get certain thing that may, cancel this x minus h. But x is what? 1 minus h in the left hand side, 1 plus h in the right hand side. So denominator of LHD will be negative h, and right hand side, right hand derivative, the denominator will be h. Now let us apply the limit. And limit h tends to 0 is everywhere. I am not writing it, but that is why I have shown you the example or answer. That is, you have to write it always. Now sine 90 minus theta is cos theta, because now you cannot put h limit directly. It is this sine something is combined with negative 1. So you will write sine pi by 2 minus sine pi h by 2. This is sine 90 minus theta. It is going to be cos theta, cos pi h by 2. So cos pi h by 2, and you have negative 1 also. Now 1 minus cos theta is simply 2 sine square theta by 2. So this cos h by 2 minus 1 divided by negative h. Since we have a negative in the denominator, let us change the position of 1 and cos pi h by 2. Please remember 1 minus cos theta is always 2 sine square theta by 2. That we will apply here. Okay. Then we'll use this negative h and whichever to solve the situation. So I am taking the negative out, or you can say multiplying negative 1 numerator denominator. It will be negative 1 minus cos pi h by 2. In the denominator you have a negative h. Negative negative gets cancelled. So 1 minus cos pi h by 2 is 2 sine square pi h by 2. 2 sine square pi, this is not cos, just cancel this cos. Pi h by 2 divided by 2, pi h by 4. So you need pi square h square by 4 square in the denominator. You need pi square h square 4 square in the denominator, and that will be multiplied to the numerator also. Because you need sine theta by theta, and sine theta by theta is going to be 1 sine, this is okay. So pi square h square by 4, pi square h square by 4 you need in the numerator also. So you already have h in the denominator, you have to have a h again in the numerator. Okay, there is one h already. Now this is whole going to be 1. Sine theta by theta is 1. So what do you get? Limit sine theta by theta equals 1. So this is going to be 1. And whatever is there, 2 into pi square by 4 square, or 2 into whatever constant is there, there is always an h here. There is one h, and when you apply the limit, whatever constant comes, limit h tends to 0 is 0. So this LHD has come as 0. What it has come? It has come as 0. Now coming to the right hand side. Now we have to just see whether it comes equal to 0 or not. If it comes as 0, it is differentiable at x equals to 1, otherwise not. Okay. Now 2 into 1 plus h minus 3. Now remember, here is a catch. The catch is when you multiply this 2 with 1 plus h minus 3, it will be 2 plus 2h minus 3. What do you get? Minus 1 plus 2h. Minus 1 plus 2h, but you are talking about 1 plus h. You are greater than 1. And once you are greater than 1, 2x minus 3x is 0 when x is equal to 3 by 2. That is 1.5. So you are already above 1. Okay? So you are above 1 but a little bit 1. Very little bit 1. So you have to convert it into negative. So modulus, when it will open, it will be negative. This is only the catch of this question. So when you open it, it will be negative of it. Okay? When you open the modulus, it will be negative of whatever is inside the value inside. So you get 2h minus 1 in the inside, but when you open it, it will be negative of this. So you get 1 minus 2h, 1 is already there. You have h in the denominator, this gets cancelled, h also gets cancelled, minus 2 is there. So the right hand derivative comes as negative 2. Now you see 0 and negative 2, they are not matching. That means this function is not differentiable at x equals 1. Though it was continuous, but it is not differentiable at x equals 1. Okay? So the continuity computation may be different from the differentiability definition, because in the differentiability you already have a 1 along with this function. So you cannot just put h0 here. You have to solve all along, and then you have to put this as combined function. Similarly, what we have done, cos h pi plus pi h by 2 minus 1. So this is a combined function. That is why we converted it into 2 sine square h by 2 or 2 sine square theta by 2. So I hope you got the idea. How did we arrive at this? The continuity is explained, but the differentiability is not, because it is 0 and minus 2. When you go to left, when you go to right, you get different result. Okay? So this kind of question, it has modulus, it has a greatest integer function, it also has the sine one. Okay, sine pi. So 3 functions are there, and you need to know the property of all of this, and with the intervals also. This interval is x greater than or equal to 1 or x less than 1. Now if fx is equal to ax square minus b, if mod x is less than 1 and mod x is greater than or equal to 1, it is going to be 1 by mod x. If this is differentiable at x equals to 1, find a and b. So the question is saying this is differentiable. It is saying differentiable, you have to find out the value of a and b. Now you already know what is the explanation for mod x. So mod x less than 1 means what, and mod x greater than 1 means what. So when mod x is less than 1, what is this? When you have mod x greater than or equal to 1. See, mod x less than 1 means it is between minus 1 and 1. But mod x is greater than or equal to 1. That means you are between, not between minus 1 and 1. Okay? Mod x greater than or equal to 1 means you are not counting anything between minus 1 and 1. But mod x less than 1 means you are counting values between minus 1 and 1. Okay? So 3 partitions there. X less than minus 1, x greater than minus 1, and here we have x between negative 1 and positive 1. So x is between negative 1 and positive 1. Okay? So there are 3 different parts. So you have to write the function for all these 3 parts. Okay? When you open this mod x, there will be 2 conditions for this mod x as well. I hope you got the idea. So let me just show it to you here, that this actual function we are changing it. Okay, for fx. So when x is less than negative 1, when x is greater than x is greater than 1, it is not minus 1, it is 1. Just change, there is a correction, slight correction here. So x is less than minus 1, x is greater than 1. So this is going to be 1. Okay. So I'm just changing it. So when you are greater than 1, it is going to be 1 by x. When you are less than minus 1, it is going to be negative 1 by x. Why? You have a mod x here. mod x is simply x is greater than 0, it is x. X is less than 0, it is going to be minus x. How about 1 by mod x? It will be 1 by minus x and 1 by x. And in which range we are talking about? We are talking about mod x. So mod this x less than minus 1, it is going to be minus 1 by x. And when x is greater than or equal to 1, it is going to be 1 by x. I hope you got the idea. You have to understand the both mods very well so that you know how we have achieved this answer. And how about x between -1 and 1? It is going to be ax square minus b. X between -1 and 1, it is ax square minus b. Now, all these differentiable functions, we know every differentiable function is continuous. So it is already given in the question that it is differentiable at x equals to 1. So it is continuous also. So it is continuous at x equal to 1. So x equals to 1, we will find out the left hand limit, right hand limit, and we will equate them. That is, you have to write 1 minus, that is 1 minus h, 1 plus, that is 1 plus h, of course. So we don't need it because the questions are already, the functions are separate. We have separated them already in different intervals. We have removed the mod x now. So we know at each interval what will be the value. Okay. So you have this ax square minus b here. And for this, when we just go a bit higher than 1, it is going to be 1 by x. So just apply the limit x tends to 1. Here also x tends to 1. You have this, when you put x as 1, you get a into 1 square minus b. So 1 square will be 1 only, so it will be a minus b. This is a minus b. Here you have 1 by 1, that is going to be 1. So left hand and right hand, it is a minus b and 1. Now just equate it. So it is continuous, that means LHL should be equal to RHL, a minus b equals to 1. Right? Now this is the first equation and we are going to use it. A minus b equals 1, we are going to use it just now. Just keep in your mind that this is our function or the relationship which we got. Now coming to the differentiability, we have just checked for the continuity. Let us check for the differentiability. So we will try to find out the left hand derivative. We will try to find out the right hand derivative. Fx minus f1 divided by x minus 1, because x equals to 1 is already given in the question. Fx minus f1 by x minus 1, this is also given in the question. So we have limit x tends to 1, you can say 1 plus and 1 minus. So LHL or LHD you write 1 minus 1, RD you write 1 plus. So when you go above 1, below 1 what is there? Ax square plus b. See, minus 1 to 1, it is ax square plus b. When you go 1 plus, when you go above it, you have to use 1 by x. So we will use 1 by x here, right? So x greater than or equal to 1, x equals to 1, x equals to 1, 1 by x. F1 is 1 by 1, that is going to be 1 because equality is from 1 by x. So f1 will be 1 in both the cases, divided by x minus 1. Here x minus 1 in the denominator, what is going to be fx? We are going above 1. So what is above 1? X is greater than 1, so you have to use 1 by x here. So let us use 1 by x here. Okay. This limit x tends to 1 will always be there. I am not writing it, but please remember limit x tends to 1 is already there. Let us solve the right one. 1 minus x by x divided by x minus 1. So what do you get here? You can change the sign, minus 1 minus x. X minus 1 in the denominator, you have x here. This gets cancelled, you get minus 1 by x, and since x is tending to 1, the limit is 1. Just replace x by 1. Okay. So see, minus is in the numerator, x minus 1 gets cancelled. So you have a minus 1 by x, and x is of course tending to 1. So you get a negative 1 here. The left hand derivative, we have ax square plus b minus 1. Now we have to get something in the numerator so that you get x minus 1 cancelled. But we are not getting it. Why not to take the advantage of what we have found out in the first discussion? That is, when we were doing the continuity, we already found a minus b equals 1. Remember? So this b can be written as a minus 1. A minus b equals 1. In the place of b, you can write a minus 1. So in place of b, just write a minus 1, and minus 1 is already there. But it is not ax square plus b. I have already, see, I have done again a mistake. I am so sorry about that. Ax square plus b, it is not ax square plus b, it is ax square minus b. So when you put minus b, this will be negative a plus 1. And denominator you have x minus 1. So by this step, I know that I did a mistake. I committed a mistake. And that mistake is simply I used ax square plus b, which is not the correct one. Ax square minus b I have to use. So this, I'm just changing it. This is, I'm changing the sign also now. So x square minus b and ax square minus, in the place of b I replaced with a minus 1. I'm doing it again just to re-emphasize that what was the mistake. X square minus a plus 1 minus 1 gets cancelled. You can take a common from here, you get x square minus 1. You can call it as x square minus 1 square. It is a square minus b square, a square minus b square, a minus b, a plus b. So into x minus 1, x plus 1, denominator you have x minus 1, you can get cancelled, a into x plus 1. Okay. So when you apply the limit x tends to 1, it is going to be a into 1 plus 1 is 2, 2a. Now LHD is 2a, RHD is negative 1. Remember? Since it is differentiable, so you can always equate the left hand derivative with the right hand derivative. Just equate it. 2a equals 1, negative 1, a is equal to minus half. So when you get a as minus half, you already have a minus b equals to 1. Put it in this equation. Minus half minus 1 is minus 3 by 2. So b is negative 3 by 2. A negative half, b negative 3 by 2. Okay. This is how you can compute it. Find the values of a and b if the function f defined by this is differentiable at x equals 1. So we have x at 1 we have to check. We have a and b, these are two different constants that we have to find out. So we need to have at least two equations in order to get a and b. That is two variables or two values to be found out. Two equations have to be there. So what we'll do, we'll start with the continuity. So left hand limit, right hand limit we are going to find out. So this is x equals to 1. And we just go a bit behind or backwards and a bit forward. So x tends to 1 minus, x tends to 1 plus will do. So we have to use the function x square plus 3x plus a when we are just going backwards to 1, and this function, and when we go just ahead of 1 we have to use bx plus 2. That is the only thing which you need to keep in your mind. So limit x tends to 1, we have to use bx plus 2 here. So apply this x as 1 here, 1 square plus 3 into 1 plus a. So 1 plus 3 plus 8 is going to be a plus 4 or 4 plus a. Bx plus 2, so b into 1 plus 2, that is going to be b plus 2. Now these two are equal. So we'll get one equation with this. A plus 4 equals b plus 2, because this is already, it is given that it is differentiable. When it is differentiable, it will be continuous also. So a plus 4 equals b plus 2. And we'll deal it with later, because ultimately we have to put a as b minus 2 in our next step. But the main equation is this, the first equation. Now we have checked for the continuity, we got the one equation. Now we'll go for the differentiability. So let me just clear it up, and we'll be discussing the differentiability here. In order to get the differentiability, left hand derivative and right hand derivative, that is what we are going to find out. And the formula remains the same, fx minus fc. C is 1 here, that is the constant at which we have to check the differentiability. So I'm writing directly f1 divided by x minus c, that is x minus 1. So left hand derivative, x tends to 1 minus, and then this is x square plus 3x plus a. This function you have to use because you are on the left of 1, and minus f1. I'll just tell you what f1 is. X minus 1 in the denominator. Here also same thing, the x minus 1 in the denominator. The function will change because you are now ahead of 1. So you are above 1, for that you have to use bx plus 2. So let us just write bx plus 2 here. And what is f1? Please remember, we have to use where x is equal to 1, and here x is equal to 1. X is less than equal to 1, that is x is equal to 1 also is given. Just put x as 1 here. So 1 square plus 3 into 1 plus a. You get 1 plus 3 plus a. That is going to be a plus 4. So just write a plus 4 or 4 plus a here. Here also a plus 4 or 4 plus a here. So let us solve the numerator first. X square plus 3a plus a plus minus 4 minus a. Now here this a gets cancelled. X square plus 3x minus 4. So we can get the factors here. You can write x square plus 4x minus x. This will be 3x minus 4. X you can take common, x plus 4 minus 1 you can take common, x plus 4 it will be. And it will be x minus 1 into x plus 4 in the numerator. And denominator you have already x minus 1. You can just cancel these two out. Please remember, limit extends to 1 is always there. I'm not just writing it just to save the time, but it is already there. So x plus 4 in the numerator. Now apply the limit extends to 1. So 4 plus 1 is going to be 5. This is your left hand limit, 5. Coming to the right hand limit, let us see what we get. So we have bx plus 2 plus minus 4 minus a. So bx plus 2 minus 4 minus a, what do you get? You have to have some x minus 1. Because x minus 1 in the denominator, as in the left hand derivative, we cancel the x minus 1 with the x minus 1, finding out the factors. Here also we have to find something in the numerator so that we can cancel it out using x minus 1. So as I said, we have to use a equals b minus 2 or a minus b plus 2. Replace this a as b minus 2. So bx minus 2, in place of a, just write b minus 2. So what do you get? Bx minus 2 minus b plus 2. 2 gets cancelled. Now you can take b common from here. X minus 1 will be there. In the denominator you have x minus 1. Now you can just cancel. Please remember, limit extends to 1 is always there. I'm just not writing it, but it is always there. Cancel these two out, you get b. So when you see that the question is saying differentiability is there at x equals to 1, so b equals 5. And what is a? B minus 2. So you can just put b as 5. A will be equal to 5 minus 2. That is going to be 3. So a is 3, b is 5. For this function to be differentiable at x equals to 1. Now this question is actually in your exercise. It is 7th or the 8th question, but it needs some discussion. That's why I am explaining it in the last, because this function is we have to check for the continuity for the differentiability at certain values. So first we will do the continuity, then the differentiability. The continuity result I'll show it to you. The differentiability result I'll show it to you. Then we'll find out what is this m. M is below 0, m is between 0 and 1, and m is greater than 1. So there are three intervals for this function where you have to tell or show whether they are differentiable, whether they are continuous or not. So all things will remain same, and you will have the expression for continuity, you will have the expression for differentiability, right? So this left hand limit and right hand limit, let us find it out. Left hand limit and right hand limit. So x equals, because we have to check at 0, 0 minus h you have to put. Here you have to put x equals 0 plus h. Please remember, I am telling you about the continuity right now. So x is not equal to 0. What you are going to replace? X raised m sine 1 by x. That will do in the differentiability also. Here equals x equals 0 minus h. You can always write it as negative h. So limit h tends to 0. Now please remember and please stick that into your mind. Always limit h tends to 0 is there. I'm not going to write it again and again just to save the time, but it is always there. So this function x m sine 1 by x, I'm replacing x by 0 minus h, which is minus h only. Here also right hand limit, what we are going to do, limit h tends to 0, x raised m, 0 plus h raised to m sine 1 by 0 plus h is h only. Now this is negative h to the power m, and sine, see this is negative, sine minus theta is what? Sine minus theta is minus sine theta. Cos minus theta is plus cos theta, but sine minus theta is minus sine theta. So let us take a negative outside, it will be sine 1 by h. Here also, limit h tends to 0 goes everywhere. It has to be written with every step. Remember, h raised to m, I am doing LHL and RHL same time. H raised to m sine 1 by h. So we have to check for the continuity, we have to check for the differentiability. Okay. Now what we'll do here is, we can make it easier or we can directly do it. So m between 0 and 1, because continuity is asked in the second part and third part. So we'll do the continuity with m between 0 and 1 and between m which is less than or equal to 0. So continuity will check at 2 points. Okay, continuity 2 points we are going to check. So this is m between 0 and 1. We can make this function or the value which we have found more easier. I'll just tell you how, because when the LHL and RHL are almost equal, we don't have to do 2 steps, check for LHL and RHL. We can just do it for both of them. I'll just tell you how to do this. Minus h to the power m. See, minus h can be written as minus 1 into h. Minus x can be written as minus 1 into x, same way. So it is simply equal to minus 1 to the power m, h to the power m. That is a into b to the power m is a raised m and b raised m. And when we have x raised a, x raised b, that is x raised a plus b. So I am just writing it again. Minus 1 to the power m plus 1, because minus 1 we have taken out from minus h. Minus was already there, so minus 1 to the power m plus 1. And h to the power m will be there and sine 1 by h. So why we have done this? Because the left hand limit and right hand limit, the value need to be, if we get it same, we don't have to do it twice. I hope you got the idea. Because this m is not going to affect at all, because we will be discussing only about h raised to power m. That is going to affect, because limit h tends to 0. It is not limit m tends to 0. It is limit h tends to 0. So m is between 0 to 1. So if you take m as 0.5, say half. So what will be h? H will be 0 to the power 0.5. Minus 1 to the power m plus 1 on the left hand limit. M is 1.5. M is 0.5 and plus 1 is 1.5. But don't worry about that. Just concentrate on h raised to the power m. So this is 0 to the power something which is 0.5, which is positive. So under root 0, 0.5 is 1 by 2. That is under root 0. Under root 0 is 0. So left hand side will be 0. Here also h is, as I said, it can be between some 0 and 1. So this 0 to the power 1 by 3, I am taking now a different example. Means half I already showed you. You will just ask, why are you not taking 1 by 3, 1 by 4, 1 by 5? So just take 1 by 3. So 0 to the power 1 by 3 is third root of 0. That is also 0. So whatever is there after this, sine 1 by h, whatever is there, it will be 0. Now sine 1 by h is already there. Minus 1 to the power 1.5 is also there. M plus 1 you can just write. That doesn't matter. Why? Because sine 1 by h, the value is between minus 1 to 1. So multiplied by 0 with any of it, it is going to give you 0. So the left hand limit and right hand limit are equal. That means the function is continuous when m is between 0 and 1. Got it? You will understand more when we just check this one. Now m is less than or equal to 0, because the continuity is asked in the third part also. Same thing, I am just taking this function which we just made. So this function has to be used for continuity everywhere. Okay, m is less than or equal to 0. Now just take m which is less than or equal to 0, but you have to check for m equal to 0 also and less than or equal to 0 also. You cannot just check for only m value of m which is less than 0, because it is less than or equal to 0. You have to check for 0 also. Okay. So I'm just putting m as, say, I'm replacing, because we are checking m less than or equal to 0. Now this is the third part we are checking. I'm taking, say, m as minus 1. Here also same thing, h raised to the power minus 1. I'm taking m as minus 1 because we have to take something less than or equal to 0. So second case already been done. Now I am showing you the third part. Please remember, this is the third part. For second part, we have already proved 0 equal to 0. So this is h raised minus 1 sine 1 by h. h raised minus 1 is what? X to the power minus 1 is what? 1 by x. So you can write, I'm not dealing with minus 1 to the power m plus 1 and sine 1 by h. This is h raised to power minus 1. You can just write it as 1 by h. This also, h raised minus 1 is 1 by h. So this is 1 by h. Whatever is there, it doesn't matter, because we know 1 by h is what? Now 1 by h, since h tends to 0, limit h tends to 0, when you take and limit h tends to 0, here also limit, as I said, limit h tends to 0 is in all the step. 1 by h is 1 by 0. 1 by 0 is infinite, it is not defined. So this is not defined, this is also not defined. So when the function is not defined for this m less than equal to less than 0, that means it is not continuous. And if you take 0, because it is m less than equal to 0, you have to check for 0 also. If h raised 0 is what? 0 to the power 0. Now 0 to the power 0 is also undefined. There is nothing called 0 to the power 0, infinite to the power infinite like that. This is also not defined. So it is not continuous in either case, m less than equal to 0, m less than 0 or m equal to 0. Okay. Now let us, I'm not cleaning it up because I have to show that how this differentiability will be checked. The differentiability has been asked for first, second, third, all the parts. So we have to check for m greater than 1 also, all these. Okay. Function, see, there are certain things which came as not defined. Please remember, we have already checked the differentiability for the third part. Because of the function is not continuous, it will not be differentiable also. The third part is already been checked. But still we'll do that step. So in the differentiability, we'll take left hand derivative and right hand derivative. This left hand derivative, fx minus fc divided by x minus c, that's what we do. Limit x tends to c. Same thing we are going to do here, fx minus fc divided by x minus c. Fx is what? X raised m sine 1 by x. Left hand derivative, we will take x as 0 minus h. Here we will take x as 0 plus h. So x as 0 minus h, x as 0 plus h. X is simply replace it by 0 minus h. Okay. 0 minus h is minus h. 0 plus h is h. Okay. Now wherever x is there, we'll put 0 h minus h and h. So minus h to the power m. I am replacing fx by minus h raised to the power m sine 1 by, since it is negative h, we'll write it negative h. And minus fc, fc is what? C is 0, because we have to check at 0. F0 is what? It is already given in the question, F0 is 0. So you don't have to write this. Don't write minus fc, fc is 0. So I'm not writing it. Okay, we have to write fx minus fc, but fc is 0. It is already given in the question. You don't write it. What is x minus c? It is minus h minus 0, because c is 0. So negative h will be in the denominator. Similarly, on the right hand derivative, h raised to the power m sine 1 by h minus, what is this minus, the value will be fc, which is already given in the 0, which we did in the LHD. So we won't worry about minus something. What is in the denominator? H minus c, which is h minus 0, which is h. Now this minus h to the power 1 it is, and here h to the power 1. Now please remember that when we have the base same, and when we have numerator and denominator, when the denominator goes to numerator, it will be subtracted. So a raised m by a raised n, it will be a raised m minus 1, m minus n. So minus h to the power m minus 1 it will be. And here we have sine minus 1 by h. So sine minus theta is minus sine theta. So I am taking minus outside. It will be sine 1 by h. I am trying to make the LHD and RHD same, the way I did it in the continuity. So h raised m minus 1, same thing, sine 1 by h. Okay. Now, since they both are not equal, so I want this negative of the LHD to be combined with the negative outside. Just if we make them equal, we just have to prove it once. So minus h can be written as minus 1 into h. So it is raised to the power n minus 1. So minus 1 to the power m minus 1 into h raised to the power n minus 1 you can write. So this minus 1 to the power 1 was already there. When we take minus 1 to the power m minus 1 outside, the power will be added. So 1 plus m minus 1. So this is 1 gets cancelled. It is minus 1 to the power m. Now minus is vanished here. We have already taken it out. So h raised to the power m minus 1 sine 1 by h. So the both the terms are equal now. Now we can discuss for any of the LHD and RHD. First case is when m is differentiable at x equals to 0, when m is greater than 1. So m is greater than 1, what does it mean? H to the power m minus 1 sine 1 by h. What is m minus 1? M is greater than 1. Let us take some value. Let us take m equals 2. The first value is m equals 2. So h raised to minus 1, which is h raised to the power 1 sine 1 by h. Now when we apply the limit h tends to 0. When we apply limit h tends to, everywhere limit h tends to 0 is there, as I indicated to you earlier. When you apply limit h tends to 0, it is going to be 0. And as I discussed in the continuity also, sine theta will always be between negative 1 and 1. 1 and negative 1. Okay. This whatever you write, whatever you put inside sine, it will always give you negative 1 to 1. When you multiply it by 0, it is going to be 0. 0 is defined. So it is differentiable. Okay. So it is differentiable. Second case. Second case is m between 0 and 1. Now when m is between 0 and 1, same thing we are going, because LHD and RHD, they are equal now. So h raised m minus 1. This we don't have to worry about. Negative is not, you will say that there is a negative raised to the power m, negative 1 raised to the power m, but it will not affect. You will just see. The limit is on h, not m. So h raised m minus 1 sine 1 by h. Now m is between 0 and 1. Just take some value. M you can take it as half, 0.5. When you put h as h raised to the power m is half. Half minus 1 is minus half. H to the power minus half is what? It is under root, but denominator under root. X to the power minus 1 is 1 by x. So h raised to the power minus half is 1 by h to the power half. This is 1 by h to the power half sine 1 by h. So when you apply the limit, h is going to be 0. Limit h tends to 0 is always there. Sine 1 by h doesn't matter because it will always be minus 1 and 1 in between. But in the denominator, you'll get the 0, and under root of 0 is 0. 1 by 0 is not defined. 1 by 0 is infinite, undefined. So when it is undefined, the function is not defined, as in the case of continuity. It was continuous, but it is not differentiable because it is 1 by 0. Okay. Now the third case, as I already told you, it is not continuous, so it will not be differentiable. But we'll just check because the question is asking that. So h raised m minus 1 sine 1 by h. That's why I made it LHD and RHD equal. Same way I made LHL and RHL equal, so that we have to just apply it for once to make your work easier. Okay. So we have h raised m minus 1 sine 1 by h. M is less than equal to 0. So when it is less than equal to 0, you have to check for less than also and equal also. Please remember. So h raised to 0 minus 1. I am taking m as 0. So we have h 1 by h. H raised minus 1 is 1 by h. 1 by h is 1 by 0. 1 by 0 is not defined, so it is going to be undefined. The function is not defined. Now let us take less than 0, because equal to 0 I already checked. Now less than 0, that is, let us take minus negative 1 value. So h raised to the power m minus 1. So minus 1, m is minus 1 here. So h raised minus 2 and 1 by h square it is. So sine 1 by h, it doesn't matter because 1 by h square, 1 by 0 square, it is 1 by 0. And 1 by 0 is there, it is not defined. Anything divided by 0 is not defined. Okay. 1 by 0, whatever you multiply, it is not differentiable. Okay. This is how it is being done. Okay. This is all about this exercise. Thank you so much. Take care of yourself.